Hey guys, a couple of people have asked me about this question here, more particularly the horizontal translation part, so this bit here. So I'm just gonna do it for you, or maybe talk about a couple of things that people might find hard or have trouble with. Before we talk about those things though, let's just look at this rule and find all those details that we need right at the start. So amplitude is something that we're going to need. So our amplitude is 3, we can see by that. We can also work out what the period is based on the coefficient of x. So the period, which is 2 pi on n, our n value is going to be 2. So 2 pi on 2, which means our period is pi. Now this bit here, if you look at it straight away, you'll probably look at this and think this is going to impact your horizontal translation, which it does, except I think what a lot of us end up doing is we forget about this 2 as well. That 2 also impacts your horizontal translation. So I'll give you an example over here of something that might be a little bit easier. So we'll do a parabola. So you could have a parabola in turning point form. If you look at this one, we can see that there's a 3 there, so we think that it's going to move over 3 units to the left, and we'd be right. Now the way we actually find that out, like that's just a quick way by flipping the sign, but what we're actually doing is doing x plus 3 equals 0, so we're making whatever's inside the bracket equal 0, which is then going to give us x equals negative 3, so it tells us we're moving 3 units in the negative x direction. Now this example didn't have a coefficient out there, so I'm going to do another example again with a parabola because it's easier, and we'll see what happens when we do have a coefficient there. I'll make it 2 just to be similar to the other one. Alright, now if we look at this, you can't just say, alright, there's plus 3 there, so we're moving 3 over to the left. That's not how it works. We need to use this method here. So we're taking everything that's inside that bracket and making it equal 0. There we go. And if we solve it, we're going to see that x is negative 3 on 2. So that shows that we're moving negative 1.5 units, or negative 3 on 2 units, to the left. So that works exactly the same over here as well. We can't forget about this 2x here when we're talking about horizontal translation. So if we tried to work out how we're moving or how we're translating, it would be 2x plus pi on 3 equals 0. And if we solve for x, we're going to have x equals negative pi on 6. So this here tells us that we're actually moving pi on 6 to the left. We're not moving pi on 3 to the left. That's really, really important, and a point where I think a lot of people have a little bit of trouble. So we're translating minus pi on 6 units left. Alright, now because we're translating kind of a funny size unit to the left when our period is pi, so it doesn't necessarily fit perfectly together, it does make it a little bit hard as well. But I'm going to try to give you a strategy here on how to work out how to make it work for you and set up that grid that helps us draw it. So I'll set up our axis first. Alright, now I'm going to forget about this stuff for now. It's going to be easier if I just work out our amplitude first. So it's going to go all the way up to 3. It's going to go all the way down to negative 3. So I'll put my guidelines in. Again, you don't have to do this, except it will make it easier, particularly with these ones where we move from side to side. Alright, now it's important that we're having a look at our horizontal translation. Normally we'd start any of our graphs from the origin here, except this one's been moved over pi on 6 to the left. I'm not just going to choose some random spot to be pi on 6. it's going to make it a bit confusing. So I'm actually going to try to make this to scale as possible, because otherwise we might muck things up. So let's just say the period's pi. Let's just say back here is pi. Now, negative pi, sorry. Now if that's a negative pi, pi is going to have to be something like this. Do it as close as I can. Okay, cool. Now let's think about our pi on 6. Now, a sixth of the way back, that's half. A sixth is probably like there. It doesn't have to be absolutely perfect, but let's try to make it as good as possible to make it easier for us. So that's negative pi on 6. And from negative pi on 6, which is where our cycle is going to start, the period is pi. So negative pi on 6 plus pi, that means the cycle is going to end around about here, which is 5 pi on 6. So we've added pi, the whole period, to that. So within that area there should be where we're drawing our cycle, because we only need to draw one cycle. That's what the question's asked us. Yucky vertical line, but anyway. Alright, so here's a couple of guidelines for us. Now, one of the things that I really want you to do every single time is split your period up into 4. So half it, quarter it, whatever you want. So I'm going to work out where they are, but I'll just put some little dashes in first to guide myself. So if the cycle starts there and ends there, halfway is around about here. Don't know what that number is. We'll find that out soon. A quarter of the way would be around about here. 3/4 of the way would be around about here. Now, we know that we're starting at negative pi on 6, and the whole period is pi, and we've broken that period of pi up into 4. So that means the distance between here and here must be a quarter of pi. That's got to be a quarter of pi. That's got to be a quarter of pi, and that's got to be a quarter of pi. I'm going to be able to use that to work out where they are. Okay, so I'm going to write this down. You don't have to, but it might make it easier if you're working with some more difficult fractions. It's better if you don't write it down, because you're going to be quicker, except it might be easier to make mistakes if you do that. So let's just write it down this time. Alright, so if we're starting at quarter pi here, if we're starting at negative pi on 6 here, and we need to add a quarter of pi on, that's like saying this. Negative pi on 6, and we're adding pi on 4. What we need to do is work out what this is. So we just need to add fractions together. Alright, so you guys hopefully know how to add fractions together. So we need to make the denominators the same. So negative 2 pi on 12 plus 3 pi on 12 gives us pi on 12. So that point there must be pi on 12. I'll label it. There you go. Now, if we know that part's pi on 12, and that's a quarter of pi along, we can work out what this spot is. So if we go pi on 12 plus pi on 4, we use the same method to work out what that point is. So we get 4 pi on 12, which can be simplified, so that's pi on 3. Put it into our graph. Now that we know that one's pi on 3, and that one's a quarter along, we can do the exact same thing. So pi on 3, and we're adding pi on 4. What is it? 12. So you need to times that by 4. So 4 pi on 12 plus 3 pi on 12 gives us 7 pi on 12. We can put that one in as well. Another reason why it's really good to work out what all those parts are, so quarters of the way through it, is all of the key points that happen on this graph, they're going to be either a quarter, halfway, or 3/4 through. So when I say key points, I mean maximums, minimums, and x-intercepts. So we've pretty much worked out every x-intercept, maximum, minimum already without even seeing the line. So let's have a look at our rule again. This is a sine graph, so it's going to start in the center or at the average. And we've got a negative out the front there. So instead of going up as we normally would, we need to go down. So it's going to go down to here. And it's a sine graph, so it's coming back to the average, then going up and coming back down. So our graph should look like that. So hopefully you can see that this point here, it's on our grid. This point here is on our grid. That's a x-intercept, minimum, x-intercepts on the grid, maximums on the grid, x-intercepts on the grid. So without doing any more working out, I've got all those key points. Now we're going to do this completely properly because we do need to show all those key points. So let's start with this one, where x is negative pi and 6, y is 0. At our first minimum down here, x is pi and 12 that we worked out before, and it's at the bottom, so the lowest level of our amplitude, or lowest level of our range rather. Another x-intercept, a maximum, we worked out 7 pi and 12 before, and it's right at the top, which is 3, and over here is an endpoint as well, and x-intercept at the same point. So our x value is that, and our y value, should that have been on 12? No, that's right. I'm thinking of that one. Okay, so we've almost got all key points. The only thing that we don't have is our y-intercept, which is just here. Now, it should probably be a little bit higher. But I may have drawn it slightly wonky. That's okay. We can still see that there's a y-intercept there. So the way we find a y-intercept is the way we find it in any other graph as well. So we're going to take our rule and just make x equals 0. Here we go. We've made our x equals 0. Okay, which comes to that. Now sine pi on 3, we're doing this kind of thing when we were solving equations, and this is something that's in our exact values table as well. So hopefully we can recall that sine pi on 3 is root 3 on 2. So that's our y-intercept. So this point here is where x is 0 and y is negative 3 root 3 on 2. And we're done. So as you can see, the grid's super important, but a part where people might make a lot of mistakes is here. This bit is a way where you can find out your horizontal translation, but that's not the only thing. You need to take into account the whole part inside the bracket. The whole part. Alright, thanks guys. Hopefully that helped you out.